Alright, in section 4.1 we talk about linear functions, and the first thing that we're going to do is talk about deciding if data is linear. So probably when you dealt with linear functions before, you were given the linear equation or the linear function and you were asked to maybe find points, find the slope, graph the line, things like that. So a lot of times in this class we're going to take those ideas and we're going to work them backwards from what you've done before. So here we're given a table of values. We don't even know if it's linear or not, we just have the points to it and we have to decide, is this linear? Well, how do we decide if something's linear? You could take those points and you could graph them, but that's not really a good way to decide because it could be kind of close to linear, or maybe our graph, by hand wouldn't look so great and it might not look linear. We can't really decide for 100% certain just by graphing the points. But what we can do is use that same idea. When we look at a line, we know when we see a line it's straight. What decides that? What makes that a line and something else a parabola or whatever? Well, think about when you're plotting that line. You know that all you need are 2 points, and that decides the line. Any 2 points that you draw that are on that line are going to be connected by the same slope. The slope is what decides that. It decides the shape of the line. So, if we have points, we want to decide if they're linear, we're going to look at the slope. So remember that we have y equals mx plus b, and m is the slope, and that's equal to y2 minus y1 over x2 minus x1, or in other words, change in y over change in x, which we use with a little triangle called delta. So if we're given these two tables, we want to decide if it's linear, we're going to look at the slope. We're going to look at change in y over change in x. Okay, so between these first two set of points, I've got x and y, so you can think of them as x1, y1, x2, y2, or in other words, just do change in y over change in x. But make sure whichever one you start with for y, you start with the same one for x. So we could do 7 minus 4 over 1 minus 0, and that would give us 3 over 1, which is 3. Alright, these are in a little bit tight here, so I'm going to do red for the next one. So between the next two set of points, I'm going to have 10 minus 7 over 2 minus 1. And again, I get 3 over 1, which is 3. So this is looking promising. I'm trying to find my slope each time. My slope for the first two matches, so this looks good. Alright, and then my last one I'm going to do in green, because I'm running out of space here. So I'm going to do 13 minus 10 and 3 minus 2. So I've got 13 minus 10 over 3 minus 2. And again, I get 3 over 1 is 3. So we can see that these three numbers match. That means our slope matches between all 3 points. And if our slope matches, if all of these numbers match, then we can say yes, this is linear. And we know that the slope is equal to 3. Alright, now if you remember back to your other algebra days, if you have a point and you have the slope, you should be able to come up with the equation of the line. So if this is linear, we should be able to come up with the equation of the line. So we've got y equals mx plus b. We know that m is 3, so we can go ahead and put that in. And we need to finish finding the equation of this line. We need to figure out what b is. There are two different ways that you can find b. You can remember that b is the y-intercept, or you can plug in any x and y to find b. So in general, you plug in any x or y to find b. Sometimes on the table you can look over here and you can see the y-intercept. Remember, for the y-intercept, we're going to have x equals 0, always for the y-intercept. So you can actually see that right here. When x is 0, y is 4. So 4 should be our y-intercept, but let's pretend that point wasn't on the chart, or maybe we just didn't notice, and let's go ahead and plug in a point to find b. So we'll use that point. We plug in 4 for y, and we plug in 0 for x. 3 times 0 is 0, and we get that 4 is b. So our equation becomes y is equal to 3x plus 4. We've got the equation aligned. You can check it with these other points if you'd like, but that one should be in good shape. Okay, so let's try this other one. Move it down just a little bit so I have more space. Okay, same idea. We want to know, is this linear? So again, we're going to look at change in y over change in x. Okay, so first set of points, we're going to have 3 minus 2 over 1 minus 0. So that's going to be 1 over 1 is 1. All right, next 2 points, we're going to have 6 minus 3 over 2 minus 1. That's going to be 3 over 1 is 3. So we stop right there. We've got 1 for the slope here. We've got 3 for the slope here. We're going to double check our math and make sure we didn't make a sign mistake, which is super easy to make. But when we double check it, we see everything's good. We see that these don't match. We go ahead and stop right there, and we say that this is not linear. The slopes have to match. So as soon as you see one that doesn't match, you stop and you say not linear. Okay, so that's the basic idea for 4.1. We're going to go over a few more things in class. We're going to go over one more of these, and we'll talk about a little bit more that's in 4.1 that should be familiar, but we'll cover it just in case.